In this tutorial, we're going to look into the requirements sheet of the Zebra model. In this sheet, we define our basic design requirements. Now, this includes our environmental philosophy. For instance, do we want the building to be zero carbon? And it also includes some basic details of the building we're designing, such as its treated floor area. So this is what the requirement sheet looks like in the model. On this side, we have a number of inputs. So in this first section, we define our energy and carbon philosophy for the building, which is essentially the requirements we expect our building to achieve. And in the second section, we define some key characteristics for the building. So we start with the space heating demand standard. This is the maximum amount of energy our building is allowed to use for heating. It's expressed per square meter of floor area and per year. And the spreadsheet is filled with default values. So the default from Passive House is 15 for this. The space cooling demand is just the same thing, but for cooling. So the maximum amount of energy we can use to cool the building. The primary energy standard is the maximum total energy we can use to run the building. Now this excludes any offsets. So if we have PV panels, this doesn't go into this. It's a gross energy. And it also includes any upstream offsets used to generate the energy. So if we're talking about electricity, for instance, it will include the energy required to extract the fuel, the energy used to turn that fuel into useful electricity. The lifetime of the building is needed because we study both embodied carbon and operational carbon. So we need a frame of reference to compare these two to see which is the dominant factor. The embodied carbon standard is the maximum amount of carbon per square meter of area that we're allowed to use to essentially build the building. So the upfront carbon. Zebra doesn't currently account for embodied carbon for maintenance of the building or for demolition of the building. So it's stages A1 to A5 only. Good practice for this at the moment is 500. And then lastly, operational carbon is the carbon needed to run the building day to day. This is the amount, for instance, used to heat the building, offset by any energy we might generate, such as from the PV panels on the roof. The aspiration at the moment is for zero carbon buildings, so 0 is the default value here. In the next section, we have the basic building characteristics. So at a complexity level of 1, you just define the treated floor area. The treated floor area is the usable area by humans, so it would include, for instance, the floor area within a room, but it wouldn't include the voids for walls or service ducts, for instance. So as a rule of thumb, if you have a building with stairs, the treated floor area is around 90% of the internal floor area. And a building without stairs, it would usually be about 97%. If we increase the complexity level, we'll see some additional inputs below the treated floor area. The first is the thermal mass level, which is the ability of the building to store heat and then release it at another time. So in a cold climate, for instance, this may be useful because a building may warm up during the day when it's hot, and then it may continue to release that heat at night when it cools down. So this can improve the thermal efficiency of a building. Typical values are between 20 for a lightweight building or 100 for heavyweight, and this defaults to 60. The heating set point is the point at which we would start to heat the building. We would aim for the building to not get cooler than this point. And the default for Passive House is 20, but you can override that value at higher complexity levels. And the cooling set point is just the same, but for cooling. So it's the point at which we would start to cool the building down. So that's a brief overview of the requirement sheet in the model. In the next tutorial, we're going to look at how you define the weather at your project location.